So this is Chapter 5, Section 4, Dividing Polynomials. We are going to divide polynomials using two different methods, long division and synthetic division. Essentially, we can divide polynomials using steps that are similar to long division that we use with whole numbers. So just to remind you, when we do long division, so like 672 divided by 21, 21 goes into 67 3 times. 21 times 3 is 63. Then we subtract, we change the sign here, 67 minus 63 is 4. Then we bring down the 2. And then we go 21 goes into 42 2 times. And 21 times 2 is 42. Then we change the sign, 42 minus 42, and we have remainder 0. We can apply the same rule with polynomials. So in this case, I have 6x squared plus 7x plus 2. This is going to be like 6, 7, 2. You look, this is like my 6, this is like my 7, this is like my 2. Even though they're separated with a plus, we're going to treat it the same way. And instead of 21, I have 2x plus 1. So make sure that's written down on your paper. All right, so the first thing we did was say 21 goes into 67. We're just going to look at 2x goes into 6x squared. What do I have to multiply 2x by? To get 6x squared. We need a 3x. So where the 3x goes, it goes right above the x term. So 2x times 3x will give us 6x squared. So I go ahead and I do that multiplication. So I put my 3x on top, and I multiply 3x times 2x to get my x squared, my 6x squared. Then I multiply 3x times the other term to get 3x. So 3x times 1 is 3x. So I multiplied the 2x times 3x to get 6x squared, and I multiplied it by the 1 to get the 3x. I got the 3x by saying, what do I multiply 2x by to get 6x squared? Then I change the sign. Over here we subtracted 63, so we're following that same process. We are going to subtract 6x squared and subtract 3x. So 6x squared minus 6x squared is 0. And 7x minus 3x is 4x. We're going to bring down the 2. Then we say, now we're on the second part. We say 2x times what? Everything's terrible. 2x times what equals 4x? Right. So the answer to that is 2. So then I come over here and I times these guys by my 2. 2x times 2 is 4x, and 1 times 2 is 2. Then I'm going to subtract those out. 4x minus 4x is 0, and 2 minus 2 is 0. My remainder being 0. So then 6x squared plus 7x plus 2 divided by 2x plus 1 equals 3x plus 2. Okay, so the process for this is we're saying x times what equals 3x squared. And you say, oh, I have to multiply it by 3x. You go, and because it's 3x, it goes above the x term in your long division. When you're doing long division, if there's a gap, so you don't have an x term, you put a 0x there. So we go 3x times x is 3x squared. And 3x times negative 7 is negative 21x. We are going to change the signs on these so that we get 0 and we get negative 29x plus 21x negative 8x. The 56 comes right on down. Then we got what times x equals negative 8x. And we say, oh yeah, that's easy, it's negative 8. So the negative 8 comes up here. And then we multiply negative 8 times x, negative 8x. Negative 8 times negative 7 is positive 56. Then we change the sign and we add those together, giving us remainder 0, so our answer is 3x minus 8. The quotient is 3x minus 8, and the remainder is 0. Sometimes we're going to get a remainder. It's going to be okay. All right, so the division algorithm for polynomials. Look how sophisticated and fancy we are. We get to use words like algorithm and polynomials. You can divide polynomial p of x by polynomial d of x to get polynomial quotient q of x and polynomial remainder r of x. The result is p of x, your polynomial, and you guys were doing this already, so yay for you, is d of x times q of x plus the remainder r of x. If r of x equals 0, then your polynomial p of x is equal to d of x times q of x, and d and q are factors of p of x. To use long division, p of x and d of x should be in standard form with 0 coefficients where appropriate. The process stops when the degree of the remainder is less than the degree of the divisor. So if your remainder has a degree less than your divisor, so this is a degree of 1, this has to be a degree of 0. So you stop when your remainder is less than the degree of the divisor. And I remember it by saying I run out of, nothing comes down and multiplies in my long division anymore. That's how I know when to stop. All right, so you're going to get questions like, is x to the 4th minus 1 a factor of p of x, which is equal to x to the 5 plus 5x to the 4th minus x minus 5? If it is, write p of x as a product of 2 factors. I'm going to need more room. I just know it. So this is going to show you how we insert the zeros for our missing terms. So we have x to the fourth plus 0x to the third, because we've got no x to the third term. So 0x squared, because we've got no x squared term. Plus 0x, because we don't have an x term either, minus 1, divided by x to the fifth, plus 5x to the fourth, minus 0x to the third. Sorry, I guess it doesn't matter if it's a plus or minus. Plus 0x squared, minus x, minus 5. If it is a factor, if x to the fourth minus 1 is a factor, what's our remainder going to be? It should be 0. Alrighty, so what do I multiply x to the fourth by to get x to the fifth? Just an x. So we are going to go all the way through. We're going to look. Where is our x term? There it is. This is going to be mega easy. So it's x. X times x to the fourth equals x to the fifth. So now I have to go and multiply that x by each of these terms. And anytime you multiply by 0, you're going to get out 0. So x times x to the fourth is x to the fifth. X times 0, x times 0x to the third is 0x to the fourth. X times 0x squared is 0x to the third. X times 0x is 0x squared. X times negative 1 is negative x. Phew. And that's the end of my call with no wheel. Okay. So now we change the sign of everything. And we add. So I just get 0 from minus 5. What is 0 minus 5? 5. All right, so does the remainder have a lower degree than the divisor? Yeah. So what does the rule say? Oh, wait, hold on. I forgot this one. Sorry, I take it back. Rewind. Here. I forgot that one. I almost. Woo-hoo-hoo. This is going to be great. Okay. So what do I multiply x to the fourth by to get 5x to the fourth? He is easy. He's your age when you start kindergarten. He is 5. So we're going to multiply x to the fourth by 5. And it is positive 5. All right, so let's do that. X to the fourth times 5 is 5x to the fourth. X to the fourth times 0x times 5 is 0. X to the third. 5 times 0x squared is 0x squared. 5 times 0x is 0x. And 5 times negative 1 is negative 1. Okay, now we can get the proper remainder. Change the sign of everything and add those down. Now my remainder is 0. Now we can say, is it a factor? Yes. Heck yes. So we say yes. exclamation point. And it wants the p of x as a product of two factors. So the first one is going to be x squared, sorry, x to the fourth minus 1. And the second one is going to be x plus 5. All right, just like when certain circumstances in the universe are in certain ways, and then we see like a solar eclipse and there's magic happens, sometimes polynomials will be of a certain form where we can use synthetic division, which is a process that simplifies long division, and it's only when you're dividing by a linear expression. So here's what I want you to write. Synthetic division, I want you to write dividing by x minus a. We could not have used synthetic division in the previous problem because this is not linear. So we have to be dividing by a linear function where we have x minus a. So we're going to use synthetic division, we're going to write the coefficients. So I want you to say write the coefficients including zeros. We're going to not write down variables or exponents. No x's, no x squareds, no x to the fourth. So it's going to simplify everything down to just numbers. For the divisor, we're going to reverse the sign. We're going to use a. In the expression it says x minus a, so whatever's up there, it's going to be like -4, we're going to use 4. If it's +2, we're going to use -2. So if it's x minus a number, we're going to take the opposite of that. This allows you to add instead of subtract throughout the process. Let me show you how that's going to work. All right, so let me show you this process. We're going to use synthetic division to divide x cubed minus 57, x plus 56 by x minus 7. What is the quotient and remainder? So what we're going to do is we're just going to write down the opposite of our a. So it's -7 there. So +7 gets put out here. Then on the inside, I'm just putting coefficients. So coefficient of my x cubed is 1. Coefficient of my x squared is 0, because I don't have 1. Coefficient of my x is -57. Coefficient of my just regular number is 56. So if we're putting together a process for this, I would say step 1 is to write coefficients. And essentially just set up. Step number 2, we are going to drop down the first coefficient. So I'm going to drop down 1. Step number 1, step number 2, drop down the coefficient. Step number 3, multiply. Seven times 1 is 7. Then we're going to add 0 plus 7 is 7. And then repeat. Seven times 7 is 49. Negative 57 plus 49 equals negative 8. And then multiply. 7 times negative 8 is negative 56. And then add. The last step is to write the answer. So when we pulled out all the coefficients, we got out all the coefficients. This time here, your last one is, when you get to the end, your last item is your remainder. So we have a remainder of 0. So in this case, this coefficient goes to the term that is 1 degree below your leading coefficient. So what's the term that's 1 degree below x cubed? It's going to be x squared. So this is 1x squared. This is 7x. This is minus 8. So the quotient is x squared plus 7x minus 8. And our remainder is 0. Alright, so with polynomial x to the third plus 6x squared plus 11x plus 6 expresses the volume in cubic inches of a box, and the width is x plus 1, what are the dimensions of the box? So we're going to do use synthetic division. This is a word problem, and we know the volume. So we're going to divide our volume by our width, and then hopefully factor that polynomial so we can get the height and the length out. Okay, so setting this up, synthetic division, I take the opposite of what's here, so it's minus 1. And then I go, coefficient of x cubed is 1. Coefficient of x squared is 6. Coefficient of x is 11. And coefficient of the constant is just that constant. We drop down the first coefficient, and then we multiply and add until we get to the end. Negative 1 times 1 is negative 1. 6 plus negative 1 is 5. Negative 1 times 5 is negative 5. 11 minus 5 is 6. Negative 1 times 6 is negative 6. And 6 minus 6 is 0. Remainder 0, yay! So we know that we can write our new polynomial as x plus 1 times x squared plus 5x plus 6 plus x squared plus 5x plus 6. So we can factor x squared plus 5x plus 6. Which two numbers multiply to give us 6 and add to give us 5? 2 and 3. So the width is x plus 1. The other dimensions are x plus 2 and x plus 3. All right, so the remainder theorem. The remainder theorem says if you divide a polynomial by any degree bigger than or equal to 1, then the remainder is whatever the value of your function is when you put in a. So we're going to test this. All right, put this in a test. Get your calculators ready. This is going to be awesome. It's going to be great. We're going to test this theory. Just in case you think they're just joking. Okay. So you set up your synthetic division. You got -4. So when it says P of A, whatever that A value is, you don't switch the sign. You just throw it right in front. And then the coefficients are 1, -3, -28, 0, there's no x squared term, 5, and 20. Don't get, we got to keep it diligent. We can't forget the ones that don't appear. Okay, first thing we do is drop it down. Then we multiply. Then we add. Then we multiply. Then we add. We multiply. Then we add. And we multiply. And we add. And we multiply. So P of -4 should be 0. As it says, whatever the remainder is, so I want you to go, let's go ahead and take a moment. Let's calculate what this is when we put in -4 and just verify that we are doing it correctly. All right. That's it. That's it. I was done. Synthetic division, done.